I think this is just a pure formula, alright, for question 8. So how much from the Nyquist plot? So once you get the Nyquist plot, alright, you can actually determine the phase margin 120 degrees, frequency 3 Hz, and a gain margin of 11.6 dB. Alright, so it's in terms of a Bode plot, I would say. Alright, a Bode plot 11.6 dB. Alright, but anyway, so in order to find your gain, so how much can a plant gain increase before a closed loop becomes unstable? So this means that if you have your current system over here, maybe somewhere over here, alright, so you have -1. So it tells us how much gain can we give in order to just at this particular point over here at -1. Right, so how much gain can we allow? Alright, so in order to do that, this is just a straightforward equation. Is that 20 log 10 your gain? This x is sum of your gain, meaning the gain that we are looking at right now. Alright, how much distance before we can reach -1, so to speak, or 1 over lambda is equals to what? Because 1 over lambda is your gain margin. Alright, so what is the lambda that we're looking at? Something like that. Sorry, what is the 1 over lambda we are looking at? Because we are looking at this distance over here. Okay, so therefore 20 log 10, you put in your x is equals to 11.6 dB. Alright, so if you were to convert back, you have x equals to 3.8. So this tells us that this is 3.8 over here. Okay, and then if you want to know what is lambda, so we know that 1 over lambda is equals to 3.8. Alright, so 1 over 3.8, you'll get your lambda. Alright, which tells us that we have somewhat 0.26 over here. Alright, things like that. Alright, but just want to let you know that this is the amount of gain that you can allow. Apparently, I may be wrong for this not my explanation, but this answer is definitely correct. Alright, so whenever you're giving a gain margin of this thing, just use the 20 log 10 to convert back. Alright, 20 log 10 is the standard one. Alright, in the past we know that frequency times delay is equals to the phase margin. Now we're asked to find our delay, additional delay. Alright, so therefore what we can do is to get our phase margin first. Alright, so we know that phase margin is 120 degrees. Alright, the frequency is 3 Hz. So I'll just simply bring this frequency downwards to the side. Alright, and you may be tempting to do that. Alright, no. Alright, the phase margin must be in terms of the radian mode. Alright, so it's 120 divided by 360. Okay, and I don't know why they didn't times pi, so I'll just leave it for you to think about it in the future. But the answer is 120 divided by 360 and then divided by pi. Divided by your frequency. Alright, so therefore in such a case, then it's just times 1 over f, your frequency. Alright, and therefore you have 0.11 over here. So what I just done is just the same thing over here. Okay, where your frequency is 3 Hz. So this is just the equations that you may need to really understand. So 120 degrees at 3 Hz. So what does this meaning tells us is that the phase margin is 120 degrees, which is somewhat shown over here for -1. Alright, but I don't know why you have to divide by 360 degrees, the ratio. Alright, and then you times 1 over 3 Hz. Alright, but in the end, we have the answer over here. So this is something that you just need to know. Alright, the equation, but in terms of why is it 120 divided by 360, alright, why if it's changing to pi, if it's changing to radian, then we should multiply with pi. But why is my pi? Alright, never mind, I can't find it. But anyway, I shall see you there in the next video for question 9. So just take note that this is just a brief one will do. For this question 8. See you.